All right. Oakley dokley. The hypotenuse. Oh, I got to turn the screen on. Ha ha ha. The hypotenuse. What do you know about the hypotenuse? Everybody always says it's the longest side. That's what I'm looking for. Because sometimes the way it is drawn does not let you know which is the longest side. Because sometimes there's perspective in things. So don't say that it's the longest side. What you should say is that the hypotenuse is across from the 90-degree angle. Now, that word across in this unit means something else, or it has a different name. Across in this unit means opposite. So if you ever go across a shape, you are going to the opposite side. Everybody cool? All right. Now, the legs are the other two sides. And they don't matter. They are the legs, the other two sides, beside the 90 degrees. They are not special yet. In this unit, the word beside means, or the word adjacent means beside. Now, all of you who've already done trig already know where I'm going with the words opposite and adjacent, but we are going to use them now as if nobody knows what they are. Now, that gives us this formula that you all know as a squared plus b squared equals c squared. The legs are a and b, and the hypotenuse is c squared. Everybody teaches Pythagoras using a squared, b squared, c squared. Everybody does it. There's a problem with that. Because if I give you this triangle, and I tell you this is x, y, and z, some of the students I have taught in my last 20 years of teaching have the nerve to say they don't know how to solve this triangle because it is not A, B, and C. None of you would ever say something that silly to me, would you? Because where are the legs here? Which are the legs? X, Y, or Z? X and Y. And what's the hypotenuse? Z. Excellent. Those same students, sometimes I'll do this. M, N, O. And they will say, Mr. Myers, I can't solve that. And I will say, kid, why? And kid will say, because it's turned around and it's not A, B, C. None of you would ever say something so silly to me, would you? Because what are the legs there? M and N. And what is the hypotenuse? Oh, excellently done. Now, you all also know that it is a squared plus b squared to find c squared, which means I take a leg and I square it. And then I add another leg and I square it. And that gets me to the hypotenuse squared. But what if I already know the hypotenuse? This finds me the hypotenuse, but what if I already know the hypotenuse? What must I then do? Subtract. You also must be aware that hypotenuse squared minus leg squared gives you the other leg squared. The other thing kids do is I give them this. I tell them this is 5. And I tell them this is 4. And then they tell me, they have the nerve to tell me that this is 5.4. Can you believe that? Every year, I have 15 or 20 kids that tell me that this is a real-life triangle. Is it? Of course not. Why? What is that, leg or hypotenuse? Leg. Is it longer than the hypotenuse? Is that possible? Of course not. So please do not make those foolish errors when you are doing this unit, because I guarantee that half of you are here because of foolish errors. You are here because, A squared, B squared, C squared, got it, nah, and not thinking about it. And then when you punch it into your calculator gives you an answer, what do? Write it down without thinking about it. And then what does your teacher think of you? That you don't know how to do math. Is it that you don't know how to do math? No. It's because you're not thinking about what you're doing. Okay? Okay. Prove it. Tell me these two answers. You have 10 seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. What is this? 17. What is this? 8.9. How did you find 17? Add or subtracting? Adding and square rooting at the end. How did you find 17? How did you find 8.9? You subtracted and square rooted. Yes? Everybody can do that, right? Because you all learned Pythagoras in what grade nowadays? I don't even know. I learned it in grade 7. When did you guys learn it? Grade 8? So 1 year later. Want to hear a funny story? I'm going to tell you anyway. When I was in grade 7, Mr. Bailey, my regular teacher in grade 7 said to me, he taught us this. He didn't teach us A squared, B squared, C squared. He taught us leg, hypotenuse. And he said, now some of you aren't going to remember the word hypotenuse, right? That's what he said. He said, if you need to, you can remember the word hippopotamus. And hippopotamus will remind you that that side is called the hypotenuse. So, Mr. Bailey taught the unit. We wrote the test. On the test, Mr. Bailey had a question. What do you call the longest side of the triangle? I wrote, what, Sihaj? Hippopotamus, because I couldn't remember the word hypotenuse. Guess what Mr. Bailey did? Marked it wrong. To this day. That happened in 1986. To this day, I can't see a hippopotamus without seeing triangles. I'm just kidding. That's not true. But I am mad that Mr. Bailey took a mark away from me for hippopotamus. I feel I should have gotten at least half credit. But anyway, I still love you, Mr. Bailey. You are a great teacher. He also took a mark off me in spelling because we had to do sentences with our spelling words. Did you guys have to do that? And my word was personally. That was the word on the spelling list. So my sentence was, personally, I think writing sentences for spelling words sucks. See what I did there? I kind of made fun of him. He took a mark off. Even though that's the right sentence and the right use of the word, and I spelt everything right. True. Would I ever do that to you? Hey, I'd change your mind there. All right. Okay. Tell me the value of x. Talk to your neighbor. Go. .9. Damon, how did you find 26.9? What did you do first? You used subtraction. So you did 35 squared minus 20 squared. and then square rooted that to get this side. Yeah, and then you took that answer, which I'm going to say is m, and then you did subtraction again. All right? What did you do, Sihaj? You found this? How? Same way? Okay. But then you got 28.7. Oh, okay. And Madeline? Same thing as Damon. All right, so none of you are correct. Does anybody want to know why? What did you do that you were not allowed to do? No, you're allowed to use your calculator. You all use this as a hypotenuse and a side, right? Sorry, everyone. That's my buddy that I play hockey with. I play goal, and I'm very, very bad at it. So whenever he texts me, it's the sound of a goal horn because somebody has scored upon me. Now, all of you said that was an hypotenuse, yes? Are you allowed to do that? Why not? This is not 90 degrees because there is no symbol there. Everybody cool? Everybody understand? You cannot make assumptions in this unit. You can only work with the data you are given. Now, if you know trig, you could have told me what x was because you would have used trig, but, right? So this one is out. You couldn't do it unless that was 90. If that's 90, you're okay, right? Now, sometimes some people do this and say, well, that means this is 10, right? And then they say, oh, well, that means this is cut in half. So if this is cut in half, this must be 17.5, and then this must be 20. Is that true? No, because you do not know that this is 90. Everybody cool? Now, why would I put it here? To see who would do it. Now, if you did that and you did your Pythagoras right, great. That's awesome. The lesson here is don't make those assumptions. Okay? Okay. What about this one? Can you do this one? It's almost the same. Can you do B? How? Right now, using Pythagoras, could you do B? Will Pythagoras work there? Why? Because it's a 90. Okay, so you could find this hypotenuse, and I'm going to call it the hypotenuse. Now, it's a hypotenuse of the of the red triangle, yes? Is it a hypotenuse of this green triangle? No. It isn't. On the green triangle, it would be a leg. But, can I do Pythagoras on that green triangle? Right now? Yes or no? No, why not? It's not a 90. If that's a 90, can you do it? Then you would use this and this, but this hypotenuse from the red triangle would become a leg on the green triangle. Does everybody understand? Okay, so we're good with Pythagoras? Yeah? Okay. I'm not going to give you the sheet on Pythagoras then. But we are going to talk about this sheet, because to do this unit, you have to be able to read a triangle. Triangles are named by the angles. So this triangle right here is triangle ABC. Could I name it triangle CAB? Would that be allowed? Yeah. Could I name it triangle CBA? Would that be allowed? Yes. Could I name it triangle BCA? Yeah, as long as I name it by the corners, okay? You will notice, named by the angles. So this is triangle ABC. Angles are always labeled in capital letters. All right? So, this green angle right here has two names. It is angle C, but it is also angle BCA, and it is also angle ACB. What do you notice is common to all three of them? What's common to all three names of that green angle? They all have the angle sign, and they all have the C. The C is the important part. You go corner to corner to corner, and the corner that you care about is the middle letter. Everybody understand? So now tell me the three names of the blue angle and the three names of the yellow angle. Write them out right near like that. So what is this guy? What are the three choices? Angle A, angle CAB, or angle BAC. Good. What about this angle? Angle B or ABC or CBA. Can everybody do that? Everybody understands? Okay. Triangles are made up of three angles and three sides, correct? We have talked about how to name the angles. Now we're going to talk about how to name the sides. Sides are named not die. Sides are named by the corners or the angle opposite. What does opposite mean in this unit? Opposite means straight across. So, this side right here, which I'm going to highlight in orange. That orange side is going to be named either CA, AC, or, and this is where it gets weird, little b. Because the small b is across from the big B. Does everyone understand? Yeah? Okay. So what are the three names? Oh, wait. And sides use caps for the corners. And I'm going to highlight that in pink. Caps if you're doing this. But small letters if you're doing the opposite. Is everybody cool? Okay. So what are the three names of this side along the bottom? What is it? AB or BA or lil c. And what would this side be? BC or CB or lil a. Can everybody name a triangle? Great. Do that down here. Go. Just put the sides on there. Just the sides. The angles, I trust you to be able to do the angles. Now, everybody should have that, right? Everybody's good? Okay. The first triangle on this page is named triangle ABC. Right? Now, if you look at the bottom triangle here, you will see that angle F and angle A are the same. Angle D and angle B or C are the same. And angle E and angle B are the same. Everybody understands this? I'm telling you they're the same. Normally we'd get out protractors and we'd measure them, but we don't have time. I'm telling you they're the same. Everybody cool? All right. So, if this triangle, the top one, is named triangle ABC, what is the name of the bottom triangle? FDE, DEF. Any other guesses? I'll tell you now, you don't have it yet. FDE. Why? You have to go in the same order. I went the little angle to the big angle to the other little angle. So I got to go in the same order. FDE. Is everybody good? Now, the other thing you need to remember from this, and normally I do a whole chart with this, if I compare angle B to angle E, and I make that fraction, then that means that side A will compare with angle F, and side C will compare with side D. All those fractions would be the same. That's how we use blueprints to build buildings. Because the little triangle on the blueprint has the exact same proportions as the big triangle in real life. Parm.
So for us, the triangle is flipped upside down.
Pardon me?
The triangle is flipped upside down.
Yeah.
Would that change the name at all?
No, you got to go in the same order. I didn't know that had happened, but that's why you probably said it differently than me. But I'm sorry, guys. I didn't know your triangle was upside down. I will have to change that. But it won't change anything because you still got to go little angle to big angle to little angle. Everybody cool? All right. So we're going to skip the next page. And we're going to skip the Pythagoras page. And we are going to go straight to this page called Trigonometry. For you people, it should be about 243. 235. Ah, well. All right. Now, once again, a great many of you have already done trig, so this is going to seem bothersome, but we're going to review it anyway to show why it works. So, use a ruler to connect A to D. So you guys just sketch it. Oh, that's a bad color. It probably doesn't show up very well. Yeah, I don't like that. Let's use pink. A to D. Everybody good? Got my line, right? Then I'm going to use the same ruler or the same move to do A to H. And then I'm going to connect D and H. And I know it's not perfect, but it's close enough. The straight line doesn't work incredibly well on this thing. Now, you will notice that I have made one gigantic triangle, yes? But I have also made that triangle, and that third triangle, yes? Everyone agrees? What is the only thing that is common to all three triangles, that is the same in all three? This angle right here, right? No matter how big I make the triangle, this angle right here doesn't change, does it? Okay, so let's compare BF to AF. How far is B to F? 3. Compares to how far is A to F? 4. C to G, if you count it, you see it is 9. A to G is 12. D to H is 15. A to H is 20. What can you say about all three of those fractions? They're all equal, right? If I compare the legs of any right angle triangle and I don't change the angle, it doesn't matter how big the triangle gets, this comparison will still be the same. So what that means again is, if I draw a plan of a triangle on a blueprint and it's this big, that angle on that blueprint will work in real life. That is why we use trig. We can use it to measure stuff without actually measuring stuff. You know those people that are on the road looking through the telescope with the laser beam at the other guy way over there? You guys have all seen that being done, right? Surveying. Those people get paid a crap ton of money. And do you know what they're doing? Grade 10 trig for a crap ton of money. That's all they're doing. And they get to look through cool laser things. Which, I mean, that's even better. Okay, so what is the general statement? Regardless of size, the ratio of one leg to the other is always the same. And this ratio, this particular ratio, is called the tangent ratio. And it is true for all 90-degree triangles. No matter what, you will change it. Or you will have the same comparison. Now, what if that angle all of a sudden changes? So now this is A. Would that still be 3/4? Obviously not. But if this line continued on to here, would this comparison between this side and this side be the same as this and this? Yes, it would. Everybody good? All right, let's put this into practice. Now, before we go any further, this is the second most annoying thing I have to do in this course when we talk about how to use your calculator for this. Everybody look at their calculator screen. Their calculator screen will look like this. There is a gray box. That is your calculator screen. On your calculator screen, somewhere you should see either a D, an R, or a G. Or you might see the word D-E-G. Or you might see the word R-A-D, or the word G-R-A-D. If your calculator screen has a D or D-E-G, put down your calculator right now. It's ready to go. Don't touch it. Does anybody's calculator show an R, a G, a rad, or grad? Does anybody's calculator show that? Put your hand up so I can see. If your calculator shows that, look for a button that says DRG and might have an arrow by it. Push that button until your calculator says D or DEG. Did yours work, Pavneet? Excellent. Did yours work, Damon? Or whoever else had their hand up back there, because I can only see hands. What? On the screen, it should say D or DEG. On the screen. All right. Now we're going to see if everyone's right. Now the next thing we have to ask is this. Some of you are going to have calculators that look backwards from the screen. Everybody on your calculator, find the button that says tan. When you push that button, does it write the word tan on the screen? If it writes the word tan, there's a proper name for it, but you have what I call a forward calculator. And that means you can do everything as it is written. If your calculator doesn't write the word tan on the screen, you have a backward calculator. And that means you must reverse this order. Okay? So now everybody, if you've got a forward calculator, you push the button that says tan, then you push 3, then you push 5, then you push equals. If you have a backwards calculator, you push 3, then you push 5, then you push tan, and you do not have to hit equals. And if your calculator is in the right mode, you will get tan 35. 0.700273, right? Is there anybody's calculator who does not show them 0.700? Yours doesn't, Raquel? It's not broken, you're just not in the right mode. This should be the only time I have to do this. Yes, see, yours says rad. It needs to say grad. So you push the DRG button or until it says deg. Now, tan 35, 700. It works fine. See, yours has an R. It needs to have a D. So you push that DRG button, which you have right there. Shift, D, you want D. Oh, crap, that didn't work. Mode. Let's try that. That didn't work. Mode 2. That didn't work. Mode 3. That didn't work. So we got to figure out how to change yours. Shift. Nope. I already tried that. Mode. I'm going to fix his first because I bet I can fix it faster. You're on D, dude. No, but you have it on D. That's what it's supposed to be.
Okay.
35 tan. Oh, wait, you have a forward calculator. Tan 35. Okay. How do I change this? Where is it? See, that should have worked. Shift clear. Ah, there we go. No. Okay. All right. Yours will have to happen later because I don't know. I don't know how to change this particular calculator. That's why this is the worst part of my day. Ah. No. Okay. Talk later. All right. So now, does yours say 15 and 45? What does it say? What's your next one? What's the B? Is it not tan 15? Okay. So what are these two decimals? That was 0.700. What's this one? What's this? 0.267. What's this? 1. All right. Now, what does this mean? Let me show you. 0.700. What is that as a fraction? It would be 700 over 1,000 or 7 over 10, right? Everybody agrees? So this is 7 over 10. What would this be as a fraction? 267 over what? 1,000. And this would be 1 over 1. Agreed? Now, so that means if I drew this triangle and I told you this was 35, how long is this side? 7, like you just did up here, right? When you had angle A, it was 3 over 4. So if this is 7, what's this? 10. In this one, if I drew this, and I told you this was 15, which is way smaller than 35, what would this be? 267, and this would be what? 1,000. If I did 45, which is bigger than that, this would be what? 1, and this would be 1. Now, if I make all of them thousands, this would be 700 over 1,000, 267 over 1,000, and 1,000 over 1,000. Right? As you can see, as the angle gets bigger, the decimal gets bigger as well. Everybody with me? The smaller the decimal, the smaller the angle. Everybody cool? That's how trig works. There's not a lot to it. Now, your calculator can tell you an angle. It can tell you the other two sides. If you have the other two sides, you can always tell the angle. Your calculator can do that too. So what is this as a fraction? It would be 3 over 4, correct? So if I drew this triangle, this would be 3, this would be 4, right? Just like our example on the front page, correct? But this time, I already know the decimal. I need to find the angle. My calculator can do that too. It's backwards. Instead of doing tan, you have to push shift or second function, whatever your calculator has. If you've got a forward calculator, you will go shift tan 0.75 equals. If you've got a backwards calculator, you will go 0.75 shift tan. Does anybody have a backwards calculator? Do I need to worry about that this year? If you're using your phone, you have a backwards calculator. You have a backwards calculator? Okay. So when you do that, what do you get? 36.86, right? So you get 37 degrees, which means how big is this angle? Because this angle was 3 and 4, right? So how big is the angle right here? It's 37 degrees. Everybody cool? There's a negative there for a reason. That comes up in grade 11. I'm not going to waste your time with it. I'm just going to erase it. Just going to erase it. But I want you to draw this triangle. What would this be as a fraction? It'd be 123 over 100, right? Yeah. Right? Because there's only 2 decimal places. So what would the triangle look like? Well, this would be the 123. This would be the 100. So since that's a big number, this would be a big angle, right? Would it be bigger or smaller than 45? Bigger, because we know 45 was 1, right? So this has to be bigger than 45. So what is it? What's this angle? 51 degrees. And this one, 2.5. Is that bigger or smaller than 51? Is it going to be bigger or smaller than 51? Bigger, because this is 225 over 10. 25 over 10, or 250 over 100. Way bigger. So what is it? 68 degrees. Is everybody cool? All right, everybody should be. For any angle in the right angle triangle, the tangent ratio compares the opposite to the adjacent. Remember, opposite means across. So in all these triangles I've drawn, this is the angle that I care about because I am doing opposite, 250, over adjacent. Opposite divided by adjacent. Everybody good? All right. Most of you have seen this already. Some of you haven't. The 3 or 4 of you that have never seen trig, are we okay right now? Yeah? All right. So let's look at this triangle right here. I want the tangent for angle A. Tangent is opposite over adjacent. Where is angle A? In this triangle right here. Is it the top, the bottom, or the one on the right? Look how it's labeled. Is it the green, the pink, or the blue? Which is angle A? There's no trick here. It's the green one. Which means this is where I am sitting. There I am. Wait, I have gray hair. And I only have about 4 hairs. So there I am, right? If I am standing there, I am in charge of this triangle, yes? What is opposite to me in this triangle right now? What number is there? 12. What is adjacent to me in this triangle? 5. Why did you not tell me it was the hypotenuse? Because the hypotenuse already has a name. He's the hypotenuse. Tangent only works with the legs. So the ratio is 12 over 5. Now, what happens if I slide down the triangle and now I'm down here at B? What's the ratio for B? 5 over 12. Everybody cool? Because now I'm down here, so the opposite and the adjacent have changed. Using this information, tell me how big is angle A and tell me how big is angle B. Go. Some of you will know how to do this. Some of you will remember how to do this. Some of you will forget how to do this. Some of you will be figuring it out for the first time right now. Who remembers how to do it and who's got an answer for me? What's A? $67, you say? 67. And what is B? $23, because it rounds up to 23. Now listen to me, ladies and gentlemen, please. I want you to actually do this. What did you have to type into your machine? So for me, I had to push second. On my machine, it's second. It's not a shift. Then I had to push tan. Then my machine, then I had to push, oh wait, I should do this in gray because I'm doing A first. Second, tan, 12 divided by 5, close bracket, equals. That's what I personally had to push. So I want you to write down what you had to push. Because, like in all math, if you can do it this once, you can do it every time. And if you write it down, you will always know what to push, even if you have forgotten trig. And the second one, of course, I had to push second, tan, 5 divided by 12, close brackets, equals. Because my calculator gives me this first bracket automatically. Some of your calculators might, some of them won't. So you have to figure it out. Can everybody do it? Because there's no point going on if people can't do this little bit of trig. Can everybody do it? Yeah? Okay. Let's move on a little bit. Does anybody know what civilization, for lack of a better word, is famous for inventing trigonometry? It's not the civilization that did it. A bunch of different civilizations on the planet discovered it at about the same time. But we here in North America give credit to one particular civilization. Do you know what it is? Egypt. Not quite. It is the Greeks. The Greeks did not invent it. It was invented in India, China, Spain, all over the place around the same time. But we give credit to the Greeks, which means we use a lot of Greek words in trigonometry. And one of the words we use is this word, theta, which means an angle. We have this, it's a Greek letter, theta. We draw it like this. It's a circle with a line through it. And that just means an angle. Okay? You have had teachers, if you've done trig already, they talk about theta all the time. All it is a Greek letter to talk about the angle you care about. If you care about more than one angle in a triangle, often they give it other Greek letters. For example, they may give one beta and one alpha. We just do it. It's just an angle. So, every trig question is exactly the same always. You are always going to have some sides or some angles. All right? In this question right here, that is the unknown thing, isn't it? So, is that an angle? Yes, because the x is inside. So, I have a theta in this question, and that theta is unknown. Everybody with me? Once I have that theta, that is where I am sitting. I've given myself black hair again, but that's okay. Once I set up camp there, that tells me what's opposite and adjacent. So what is opposite to me in this triangle? 23. What is adjacent to me in this triangle? 15. Now I know that tan of any angle always equals opposite over adjacent. Well, theta is x. So tan x equals 23 over 15. How do I solve x there? I don't know the angle, so it's exactly the same as the question we just did. Tell me what x is, go. It's exactly the same as the question we just did, and you just wrote out what you did to solve it. And what do we have for an answer? 57 degrees. It's actually 56.88, but degrees we don't use decimals for. Degrees use minutes and seconds like time. So don't worry about it. Everybody cool? All right. Now, if something works once in math, how often does it work? Always. So let's look at this next question. Do I have a theta? Is there an angle I care about in this question? What is it? 15. Once I have 15 set up, that is where I am going. Now, what is opposite to me? X. What is adjacent to me? 37. And I know that tan theta equals O over A. Tan of what number now? 15 equals O x over A, 37. Now, just this morning, we practiced this, didn't we? When the number was on the bottom, what did we do? We multiplied. I don't even need to show you, but I'm going to anyway. When the number was on the bottom, oh, it's in the review. When the number was on the bottom, we multiply. So what are we doing in this one? Numbers on the bottom, so we are going to multiply. 37 tan 15. Now, if you're a backwards calculator person here, you need to do 37 times 15 tan, right? Or 15 tan times 35. What is your answer? Or 37. What is your answer? You don't have to write the second bracket on your calculator. No, you don't have to. What is your answer? Oh, I lie, Madeline. Some calculators you do. I found this out recently. I'll talk about that in a second. When you punch this in, what do you get? This might be weird, and it's going to be, because Madeline's got a weird number. What do you get? 9.91, right? We're allowed to use decimals for sides. Was everybody able to get their calculator? Show them 9.9. Okay, good. Yeah, you just push. Yeah. Now, the last one. Do I have a theta? What is it? 70. Which means theta is where I go. What is opposite to me? 14. What is adjacent to me? X. Tan 70 equals opposite 14 over x. What do I do when the x is on the bottom? What do I do? When the x was on the top, I multiplied. Now it's in the opposite spot. So what do I do? Divide. 14 divided by tan 70 equals. And tell me what you get there. What do you get? 5.09, so 5.1. Is everybody cool? That's trig. Now, listen to me. You have a test tomorrow, second block. You're going to go home and study. But you are also going to do just page 237. That's it. Okay? But I want you to do page 237. I want it done when you walk in here tomorrow. When is your test? What block? Second block. It gives you time to wake up and time to get here. Everybody understand? Other way around. Get here and then wake up. Because I know you guys all roll out of bed at like 7:45. And I can always tell who does that because they all look away as soon as I say that. Like Sayaj and Rajveer. Oh, no, not me. No. I'm up early getting myself all ready. Lies. How many people get up before 7 to come to school? You guys are crazy. I live in Chilliwack and I get up at 6:45. But of course it's summer, so I don't shave. One year I let my beard grow the whole summer school. My wife was pissed off. But what are you going to do? It's my face, right? I used to have a beard, just a little one, and she was like, that was okay. And then I went, even down here. Then she said that was not okay. I got in trouble. She said, go shave. I said, yes, dear. All right. Day is over in 3 minutes. Test tomorrow.